Question 15c. The shaded region is enclosed by the curve y equals x cubed minus 7x and the line y equals 2x as shown in the diagram. The line y equals 2x meets the curve y equals x cubed minus 7x at O 0, 0 and A 3, 6. Do not prove this. Part 1. Use integration to find the area of the shaded region. The line y equals 2x is higher than the curve y equals x cubed minus 7x between x equals 0 and x equals 3. Hence, the area is the integral from x equals 0 to x equals 3 of 2x minus x cubed minus 7x in brackets dx. Expanding the brackets and collecting like terms, that equals the integral from x equals 0 to x equals 3 of 9x minus x cubed dx. Performing the integration, we get 9x squared over 2 minus x to the power of 4 over 4 from x equals 0 to x equals 3. Applying the limits of integration, we have 9 times 3 squared over 2 minus 3 to the power of 4 over 4 minus 0, which equals 81 over 4 square units. Part 2 has been omitted since Simpson's rule is not covered in the current syllabus. The point P is chosen on the curve y equals x cubed minus 7x so that the tangent at P is parallel to the line y equals 2x and the x-coordinate of P is positive. Part 3. Show that the coordinates of P are root 3, negative 4 root 3. Taking the first derivative of the function y equals x cubed minus 7x, we get dy dx equals 3x squared minus 7. Now dy dx gives us the gradient of the tangent at any point on the curve x cubed minus 7x. Now the tangent at point P is parallel to the line y equals 2x, which means the gradient of the tangent at P equals 2. Hence dy dx equals 2 at point P. So we're going to solve for x the equation 3x squared minus 7 equals 2. Adding 7 to both sides of the equation, we get 3x squared equals 9. Dividing both sides by 3, we get x squared equals 3. Then taking the square root of both sides, we get x equals plus or minus the square root of 3. But we're given that the x-coordinate of point P is positive. Hence, x equals the square root of 3. The final step is to find the y-coordinate of point P. So we're going to take the x value we just found, which is x equals the square root of 3, and substitute it into the original function, that is, the function y equals x cubed minus 7x. So y equals root 3 all cubed minus 7 root 3. Expanding this bracket here, that equals 3 root 3 minus 7 root 3, which equals negative 4 root 3. Therefore, the coordinates of point P are root 3, negative 4 root 3 as required. Part 4. Find the area of triangle OAP. I'm going to present two different solutions to finding the area of triangle OAP. The first solution uses the area rule of a non-right angle triangle formula. That is, area equals half times A times B times sine C. So I'm going to find the length of OA, the length of OP. I'm going to use the distance formula for both. I'm going to find the size of the included angle by finding this angle here and this angle here relative to the x-axis, and they're two adjacent angles, and we can add those two together. So angle AOP is equal to inverse tan of 6 over 3 plus inverse tan of 4 root 3 over root 3, which equals inverse tan of 2 plus inverse tan of 4. I'm going to leave that in exact form. Now length OA by the distance formula is the square root of 6 squared plus 3 squared, which equals root 45. The length of OP is equal to the square root of root 3 squared plus negative 4 root 3 squared, which equals root 51. And the area of triangle OAP by the area rule is half times A times B times sine C. So that equals half times root 45 times root 51 times sine of inverse tan of 2 plus inverse tan of 4, which equals 15.588,45727 square units. The alternative solution involves splitting triangle OAP into two smaller triangles, finding the area of each, and then adding them together to get the total area. So I'm going to start off by drawing interval PB, which is the vertical distance between point P and the line y equals 2x. Now the x-coordinate of point B is the square root of 3, since point B is directly above point P. So we need the y-coordinate of point B, and we get that by taking the square root of 3 and then substituting it into the equation y equals 2x. So the y-coordinate of B is 2 root 3. Now the length of PB is the difference between the y-coordinate of B and the y-coordinate of P. So it's 4 root 3 plus 2 root 3, which is 6 root 3. Now the significance of PB is that it serves as a common base between these two triangles, that is triangles OBP and ABP. Now if we consider triangle OBP, the base of that triangle is 6 root 3 units. The height of this triangle is root 3 units. If we consider triangle ABP, the base of that triangle is 6 root 3, but the height of this triangle is the difference between the x-coordinate of A and the x-coordinate of B. So it's going to be 3 minus root 3. So to get the total area, it's going to be half times base times height. So that's for this triangle here. So half times 6 root 3 times root 3 plus half times 6 root 3 times 3 minus root 3. Multiplying that together, we get 9 plus 9 root 3 minus 9. The 9s will cancel, and we get 9 root 3 square units.